Hello friends, today we are going to start with the new module, that is module number 3, measurement of the pressure. Okay, as we are much aware of the things that the pressure is the one of the very important parameters in our day-to-day life, as well as the from the industrial perspective as well. So the measurement of the mm, pressure is a very essential to understand the various processes happening around us. Just like the in our day-to-day life, we can go to the any clinic or the hospitals. First, they used to measure the our blood pressure, and yeah, on that basis, they decide that the what kind of the treatment can be given, whether to give or not to give. Okay, so this is whereas the we can have the in our day-to-day life as kitchens, we can use the gases, right? So how much is the pressure inside, or in the research purposes, the amount of the pressure used to do the reactions, or else the from the industrial processes such as the measurement of the pressure or the amount of the flow of the liquids or the fluids into while just deciding the amount of the material to be flowed in or the gases flowed in for the manufacturing of the various components. Okay, so this is actually the measurement of the pressure or and the vacuum. Okay, so they are the one and the related with the one another. Okay, measurement of the pressure and the vacuum is highly essential in the continuous industrial processes such as the liquids or the gases, or sometimes both are required. Okay. So necessary to measure the it is not only necessary to measure, actually control of the pressure of the liquid and the or the gas to avoid the many hazards, so that we can keep the control or the watch over the pressures of the liquid and the gases. Because nowadays we can maybe are sometimes many times we hear that there are very fires are happening, or the gas leakaging happening. So this is negligence of the control over these pressures of the these gases or the liquids ones, so that we can just avoid the many accidents if we keep close look over the control of the pressure. Hence, the pressure measurement is one of the most important of the all process measurements. Uh, Quantitative measurement of the flow rates and the mass flow rates of the gases or liquids is of the great interest of the many fields of the process control. Actually, process control mainly depends upon this determination of this flow rates of the liquids and the or the gases. Okay, in the present chapter we will try to discuss the types of the flow and the uh, uh, its properties, and we'll try to understand that the how to measure the these flows by using the various methodologies. Now, what is mean by the pressure? This is one of the important physical quantity, and is defined as the amount of the force applied per unit surface area on which it acts normally. So, actually, this is something that the amount of the force acting or the applied tangentially per unit surface area, so gives us the pressure. So pressure is a scalar quantity, because we are the tangential force we are just trying to apply, though it is a force, but in the quantitative manner we must consider it is only the tangential component. The SI unit, the SI unit of the measurement of the pressure is Pascal, and it is equal to the 1 Newton per meter square, the square. No, and other than these SI units, there are various non-SI units are also, or the CGS units are also, and not only the CS, there are the various non-SI or the CGS units are also used for the measurements. Such are the pounds per square inch, that is PSI, and the bars are used initially or the primarily. The CGS unit of the pressure is Berry, the BA, and is equal to the 1 dyne per square centimeter, or 1 BA is equal to 1 dyne per centimeter square is equal to 0.1 Pascal. This is the interconversion between these two, the three different units. The technical unit is also there. The one atmospheric pressure. Okay, one atmospheric pressure is equal, or technical atmosphere is equal to 1 kg per centimeter square. As a system under the pressure has the ability to work on its surroundings. So obviously the this whichever the system we consider, obviously it exerts the pressure on its surrounding, and it is given by the measure of the potential energy per unit volume. Its unit and its unit can be joule per meter cube. Potential energy is measured in the joule, and the volume unit is a meter cube. So joule per meter cube is also one of the unit for the measurement of the pressure. Some meteorologists use the hectopascal for the atmospheric air pressure measurement, which is equivalent to the older millibar. Okay, which is equal to the older millibar over here. Then the pressure has the ability to displace a column of the liquid in the manometer. Manometer is something like the small capillary, and it also expressed as the depth of the particular fluid, that is of Hg, or the centimeter of the H2O. This is how they are used. Means the pressure will just what you can say, the displace the fluid in the manometer in of Hg, or else the centimeter of the H2 water. The pressure also measured in the torr. Okay, one of the very important unit in the research purposes. The most of the units, the most of the systems uses the pressure under the or used the unit as a torr in the research purposes. 1 of Hg is equal to 1 torr. The manometer unit is used in mod of the world. Blood pressure is measured in the of Hg, and the lung pressure is measured as a cm of the H2O. Underwater diver uses the meter sea water at MSW, or the foot sea water as a units of the pressure, that is 1 MSW is equal to 0.1 bar. There are the various units used, and its corresponding conversions has been shown on this chart. Okay, that is Pascal, bar, kilopascal, megapascal, pound, PSR, pounds per square inch, kilogram per square centimeter, and the inch of the mercury column. Okay, so the interconversions has been given over here. Also, the other unit conversions, and is quite important to remember the things, to understand that how we can convert the one um, unit of the pressure into the other one. So look into this chart. Okay, thank you.